Today's video is on measures of center. Specifically, students will find measures of center when given a set of data. Now, we've already learned about the most popular measure of center, which is the mean, which we typically refer to as the average. But typically, there are actually three different measures of center that we learn. And so the mean we already know is calculated by taking the sum of the data and dividing it by the number of values. Then we also have the median, which is the middle number in an ordered set of data. And then finally we have the mode, which is the value or values that occur most often in a data set. Now, these are going to be the two main goals of today's lesson because we've already kind of learned mean. And so our goal is to understand that the median is the middle number in an ordered set of data, and the mode is the value that occurs most often. Here are the notes provided by the textbook, and again, you can find these in your textbook. So a measure of center is a measure that describes the typical value of a data set. The mean is one type of measure of center, and here are two others. So the median, you order the data. For a set with an odd number of values, the median is the middle value. For a set with an even number of values, the median is the mean of those two middle values. We'll spend some time looking at that. And then the mode is the value or value that occurs most often. And data can have one mode, more than one mode, or no mode. So when all values occur only once, there's no mode. So we'll talk about that as well. We're going to go back to some baseball. I know that a couple of you really wish that baseball season was going on. We're going to use some statistics from a very popular former Philadelphia Philly, Ryan Howard. Ryan Howard was the first baseman for the Phillies when they won the World Series in 2008. You ask your parents about him. He's certainly popular in this community because of his home run hitting prowess. So we're looking at some statistics from Ryan Howard's career, and we're looking specifically at his home runs. And you can see early in his career he was not hitting a lot of home runs, but he also was not playing a lot of games. That GP stands for games played. But as you can see, in 2006 he had 58 home runs, and in that title year he had 48, and then it gradually decreased again later in his career. So we're going to go ahead and look at these statistics as they relate to the three measures of center, because the idea of a measure of center is to have one number to represent a group of data. So when we look at this, Ryan Howard, his home runs were spread out all over the place, but we can have one number that would represent how good a home run hitter he is, and that would be a measure of center. So the first is the mean, and we can calculate the mean by going ahead and adding up all the home runs and dividing by how many seasons to find out that he hits about 33.3 home runs per year. But see, median is interesting because it also gives me a measure of 33. And median, you can see I ordered the home runs by the lowest amount of home runs to the highest amount of home runs and picked the one that was in the middle. And so you can see 33 was right in the middle of the data, and that can be very representative of a data set. Finally, mode is the number that occurs the most. And in this case, there's no mode because every single season was a different number. So we're going to actually take some data collected by a former year. I asked students to name some famous people, and then once we named the famous people, we counted how many letters were in their names. I'm going to go ahead and put this data in order with the use of a dot plot. Now, we know dot plots from previous lessons are a great way to order data as we collect it. Now, some students, when ordering on a dot plot, might try to find all the 12s and put all those dots at once. A better strategy, which I'm going to display right now, is to go ahead and put them in as you collect the data, as if students were calling out the names right now. And you'll notice that I've made my dot plot to start at 7 and end at 17. However, there are no names that started with 7, that only had 7 letters, and there were no names that had 17. I had made this dot plot before the students gave the suggestions. So we'll go ahead and plot this data in this dot plot. So Ariana Grande, 12 letters, Donald Trump, 11, Pelosi, 11, Wentz, 11, Jordan, 13, Jackie Robinson, 14, Mike Trout, 9, LeBron James, 11, Bruno Mars, 9, Ashton Kutcher, 13, Aretha Franklin, 14, Barack Obama, 12, Julius Erving, 12, Dwayne Johnson, 13, John Cena, 8, Harrison Ford, 12, Joel Embiid, 10, and Katy Perry, 9. Now that I've got the data in the dot plot, you can kind of see the data clusters here at 11 and 12. You could count the number of letters in your name and see where you would fit on this graph, but you can see that the data definitely clusters right in that zone. So if we're talking about mode, very easy to spot because the two tallest towers or the peaks are 11 and 12. So this data has a mode of both 11 and 12. Now if I wanted to find the mean, I would need to add up all these numbers and then divide by how many terms. But you can see by putting them in this plot, I can kind of find where the middle of the data is nice and easy. However, I can't just say, well, it's between 11 and 12 because those are the two middle numbers, or it's 11 just because it's the middle. I have to recognize that there are 2 14s and 3 13s and 4 12s. So what I've got here is I've created these same numbers on a number line, but what I did was I made the spacing exactly the same by putting them in text boxes. And what I want to show you is if I fold this directly in half, right in the middle is the number 11. And so that shows me that 11 is the middle number. The other thing I could do is I could count. So you could see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers to the left of the middle, and 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers to the right of the middle, clearly indicating that 11 is the middle item in this data set. So that's pretty straightforward. So the median is definitely 11, and the mode is both 11 and 12. What I've done is I've added our friend Joey McAwesome to the list. Now, you could probably assume that by adding Joey McAwesome to the list, not only does it add a number, but it might change where our median is. It's not going to change our mode because, as you remember, 11 and 12 are the most popular by a good bit, and Joey McAwesome has 13 letters in his name, and previously there were 3 examples. So wait a minute. If we take a look, that means that my dot plot would now have another 13. And so now I would actually have 3 modes in my data. So by adding Joey McAwesome. I've also got another number line that I've created that has all those numbers in it. And I've included Joey McAwesome now. So you can see that there are 4 13s. And I'm going to fold this paper again. But you're going to notice now the paper folds directly in between the numbers 11 and 12. And what that means is the center of my data is not actually part of my data set. So you can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers to the left of the middle, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers to the right of the middle, which means that my middle number is actually in between 11 and 12. Now, most of you probably know that the number that comes between 11 and 12 is 11 and a half, and so that's super easy for you to solve. But the other alternative to solving this would be to simply add 11 plus 12 and then divide by 2. And you can see 11 and a half is what you get. So to make things a little simpler for you, when you've got 2 middle numbers, what you can do is find the mean of those 2 middle numbers to know your median. That can be a little confusing. So let's talk about a couple of things. First, does the median always have to be a number in the data set? And no, it doesn't. In the example I just did, our median ended up being 11 and a half. And 11 and a half never happened. There was nobody with 11 and a half letters in their name. And does the median always have to be a whole number? Well, just then we proved that 11.5 is not a whole number. So let's go ahead and take a look at this data set. These are some decimal numbers, and let's find the median in mode. Now I will say, to find mode, you don't have to put the numbers in order, but it certainly makes it a lot easier because what we can do is we can make sure we see which numbers are next to each other that are the same number. So we're going to go ahead and put the numbers in order. Oh, you know what? These numbers are already in order. That's so convenient. So let's go ahead and see if we can spot any numbers that are the same. And it helps to read them aloud. 6 and 2 tenths, 6 and 7 tenths, 8 and 3 tenths, 8 and 3 tenths, 9 and 2 tenths, 9 and 4 tenths, 9 and 4 tenths, 9 and 4 tenths, 9 and 6 tenths, and 9 and 9 tenths. Now, a lot of people might have incorrectly looked at those 2 numbers and said, boom, that's my mode. It occurred twice. But you'll notice that 9.4 occurred 3 times. And so remember, the mode is the number that occurs the most in a data set. So my mode would definitely be 9.4. Okay, but the median, we got to find the middle number. So the best way to do this is to count how many numbers are in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 numbers in the data set, that means that this is the upper half of the data set and this is the lower half of the data set, which means this right here is the middle of my data set. So to find my median, I need to find out what number comes between 9.2 and 9.4. Now some of you might have an idea, but just in case, let me go ahead and follow that second direction and add 9.2 plus 9.4 and then divide by 2. And sure enough, it is 9.3. Many of you probably spotted that and knew it would be 9.3. Just be aware when you're doing problems like this, they don't always come out so convenient. So for example, if my middle numbers were 8.6 and 9.3, that's a little harder to know what the middle number is. So again, that strategy of adding up the two numbers, 8.6 plus 9.3, and dividing it by 2, that's a great way to get that answer, and be certain it's the correct answer. All right, so here are a couple of examples of finding the mode. And so if I wanted to know the mode of the student ages here, and you can see, again, you can read them out loud, but here it's very obvious there are way more 12s than 11s, so the mode would definitely be 12. So definitely 12 is the one that occurred the most. When I look at the number of siblings in this example, you can see 1 was repeated, 2 was repeated, 3 was repeated. So let's count how many, obviously 1 is not the mode. Let's count the 2's. 1, 2, 3, 4, 5. And then the 3's, 1, 2, 3, 4, 5. So actually our mode is both 2 and 3. So you can have a situation where you have more than one mode. And then finally, for finding the student heights here, let's count. We got 53 inches, 55 inches, 56 inches, 58 inches, 60 inches, 63 inches, 67 inches. Now, some people might say, no, there's no mode and put a 0. But wait a minute. That tells me that there's multiple students who are 0 inches tall. That's definitely not correct. So what we want to actually write is no mode, because there was no number that occurred more than any other number. The main reason we use mode in a data set is how we, when we collect data that's not numerical, like in a survey sometimes. So if I asked students what their favorite type of movies were, you can see that these aren't numbers. So I can't find the middle item or add them up and divide. But what I can do is put them in a tally chart and see that comedy had occurred the most, and therefore comedy would be the mode. The last thing we're going to do is just an example to find the mode and the median of two different sets of data. So I'm going to go ahead and do that right here. So I'm going to put the numbers in order first. So 4, notice I'm crossing them off as I write them down. 5, 8, 9, let's see, looks like 12, 13, 17, 20, and 20. And so again, this is a good example when reading them aloud and putting them in order makes it really easy to spot. The mode is most definitely 20. Now let's count how many terms there are. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So with 9 terms, there are 4 to the left, 4 to the right, and then 12 would be the middle. So my median is definitely 12. Some people might try to say 13 is the middle here because these are single digit numbers. They don't take up as much space. So this is why I typically underline and double check the counting. 1, 2, 3, 4, 1, 2, 3, 4 to make sure I've got the same amount of terms to the left and to the right of what I perceive as the median. That grid paper that I used before, or graph paper, would also be a really handy way to kind of double check that work. So now we'll take a look at this last example here. And again, we're finding the median and the mode. So we're going to start by writing the numbers in order from least to greatest. So 75, 80, 90, 100, 102, and 110. You can see I almost wrote in the wrong number there, but I luckily caught myself. So in this case, I don't see any numbers that were repeated. So what I'm going to write for my mode is no mode. And then as far as my median is concerned, I'm going to find the middle number. And I can see right there, there's 3 numbers to the right, 3 numbers to the left. My median comes between 90 and 100. Now, many of you can do that in your head, and that's fine. But if you wanted to double check, we can use that calculator, and we can go ahead and add 90 plus 100, and then divide that by 2 and find the mean. And that would be 92, or 95, I'm sorry. And so 95 would be the median of that data set. All right, so our goal today was to understand what the measures of center are. And in this case, we know that the mean, we learned earlier, is the sum of the data divided by the number of values. The median is the middle number in an ordered set of data. And the mode is the value or values that occur most often in a data set. Good luck on your Google form.